This next section is all about data import, and we're going to be starting from scratch with this one. So whichever stage you're at, perhaps save your work and then go File and New to ensure that we're starting from a completely blank screen here. Then the next thing to do is a File and Save As, and we're going to save this as exercise 4. So in the Save Work Here directory, it's going to be exercise 4. So data can be imported from a variety of sources into InfoDrainage, and the purpose of this exercise is just to show the various different ways, various different data sources that it can come in from. So it's not as if this is a recommended method of receiving the data. This is just a few examples of the options which are available. So we've talked previously about the various sort of building blocks which are available, and we're going to start with one of the main building blocks, which is the junctions or manholes, and I'm going to assume that they come in from a CSV file. Now you can see there's an import directory up here, and it lists the types of information that we can import and the various data sources. However, the other way of doing this, perfectly acceptable, is to do it from the tree view, and then that's what we're going to use now. So right click on the junctions, and the option we're going to choose is import from CSV. You'll see in here there's two types of data available, CSV or Excel spreadsheet data, very similar formats. We're going to be using the CSV data today, so make sure that button's ticked, and then we're going to find a file to import. It's going to be in our data directory, and there's just one file available called manholes. Once you have that file selected, press next. Now this gets us through to a screen where we're actually interrogating the raw data. So if we opened this in a spreadsheet, this is how it would appear. There's one row of header information here telling you which type of data is in each subsequent column. What we're going to do is during the import process, the InfoDrainage needs to know how many rows of information constitutes that header data. So it's one row in our case. Next, it's asking, okay, so this is divided into a series of columns. What divides those columns? Is it a comma, a tab, space, or something else? So we're going with the comma delimited CSV, comma separated variables. It's obvious in this case, not so obvious if you bring in Excel spreadsheet data. So we've got one header row and then the series of columns to give us the data. Click next. Just as if we were creating a new node type, it gives us three options: the manhole, simple junction, or standard manhole. We're going for manhole in this case, and then press next. Now this screen is divided into two halves. On the left, this is the information that InfoDrainage needs. So for example, every manhole is going to need a name. And on the right here, this is the information being read from the CSV data. In other words, this is the data that our source data can provide. And this bit is all about marrying up kind of what you need on the left here with what you can get on the right here. And one of the things to emphasize at the moment is that you can do this multiple times. So for example, you could have one set of source data to provide you with the location, the eastings and northings of the manhole and its name, and then you could bring in subsequent data sources to provide you with the diameters, the cover levels, that kind of thing. So in all imports, it's not a kind of, it's not do it once. You can, if you want to, bring in a variety of different data sources to create your manholes, your pipes, whatever you need. So the way we match things up is you first pick the thing that you need on the left hand side, and then pick the column heading that can provide that data on the right. So for example, here we've got the name of the manhole. This is going to come from a column called MHNO, so manhole number. So in other words, it doesn't have to be named in accordance with the column headings within InfoDrainage. That's what you're doing at this stage, is you're marrying up the two. So what we call name, we're going to get from a column called MH number. So once you've married up those two, press add, and then it makes that connection there. So in this case, there's 4 things that we're going to bring in. We've got the name of the manhole. We also want the diameter of the manhole. That's going to come from this column here called manhole diameter. Add that in. Now at this stage, it's very important to concentrate on the units. We've got a value of 1200 here, so fairly obviously it's not 1200 meters diameter, it's going to be 1200 millimeters. The only other 2 bits of information that we get from this particular data source is the easting. So it's called easting in InfoDrainage, and it's going to be called easting in the source data. Add that in. This time the units are going to be in meters. We'd perhaps have to check the source data, but 53445, that looks like a value in meters, and do the same for the northing, so add that in. Okay, so we've married up what we need on the left with what the source data can provide on the right, and then just press import. So it does that import. It's identified 40 separate rows of data, so it's going to create 40 junctions. Press OK, and that comes in. So if it doesn't appear immediately, first you can check that they have appeared in the tree view there, but then it should just be a case of pressing the extents, and it zooms to the outline of the model, and we can see the 40 manholes here with their names coming from the source data. Next set of information we're going to import is going to be the connections or pipes. Now that could be similarly from a CSV file, but just by way of example, this one's going to come in from a GIS file. So right click on the connections and import from GIS. Again, a variety of similar data sources are available to us. Today we're going to be using shapefile, so select and underneath the data directory find the pipes only lines here. Okay, so we've selected that, click next. It's identified, it's just showing us a picture of where they're going to go. At this point you can change the color as they're going to appear here if you want to. Check the units and press next. And just like with the manholes, it's identified that connections can cover a variety of different types of pipes, channels, etc. So we want pipes in this case. It's going to automatically make that connection to the manholes. And then again, we go through this process of this is what the information that we need on the left, and this is what our data source can provide on the right. In this example, we're not taking anything from this information. This source data is not providing us with any of the attributes. It's simply providing the connections from one manhole to the next to say in which way does it connect up. So literally just the location of the pipes, their start and end points. That's what it's doing, and that's based on its geographical location. So at the moment it's just a line in space, but it's going to import that line and recognize that it's connected to a manhole at its upstream end and a manhole at its downstream end. So just press import on this one, and it comes in, tells us that it's going to be 39 pipes imported, and then they are. And if we had a look at this in any format at all, we would see there's really not any sort of information. We could bring that information in from a different data source, or we could design the pipes directly within InfoDrainage. Okay, the third main building block is that we're going to import the inflows. So similar process, right click, import, again using GIS as a data source here. It's going to come in as a shapefile, and this time it's going to be the subcatchment boundaries. And again, we're not providing any of the parameters here, we're just providing the location of them. Again, very similar process. We can see these would have been digitized in our shapefile, and just bring them in as catchment areas. So just import them, and it's brought in 28 of those. So we've now got our basic model built as quickly as that. Obviously there was a lot of work that was done outside of InfoDrainage here, principally sort of digitizing these inflow areas putting in the characteristics of the manholes, etc. And what you can see it's done is it's taken the polygon and it has made some sensible assumption about which manhole it drains to. Now you could include that in the source data. The source data could include a field which tells it which manhole it drains to. We didn't include that. We literally just had the polygon boundary that was imported. So InfoDrainage has made some sensible assumption about which manhole it's going to drain to. Often there is just one manhole within the polygon boundary, and so it's fairly obvious that it should drain to that one. In situations like this where we've got more than one manhole within a polygon boundary, I think the assumption is that it drains it to the one which is the most upstream. However, if you don't like that assumption, you can just right click and reconnect the inflow and then specify which one of the other manholes you want to drain it to. So that would be in situations where there's either multiple manholes within a polygon boundary or no manholes at all within a polygon boundary, and then you'd have to specify which one it goes to. Now, one final thing that we're going to do at this stage is we're going to import some surface data. And those of you who followed from the beginning will know that we started with this right at the start. We loaded a surface. So again, it doesn't matter which order you do these things in. You can load surfaces as a starting point or near the end. Now in this case, again, if you'd followed right from the start, you'll know that we imported some data from a variety of these formats and then saved it as a very specific InfoDrainage format. And that's the format that we're going to load from now. So if you click on the load from button, and then there is one in the in the data directory, but also you can go to the save work here, and this is the one that was created in exercise 1. So either's fine. I'm going to use the data. Populates that and then press OK, and it's bringing that surface data in. Now at this stage there is a message. What's happening is these manholes have cover levels which have been specified, and at this stage it's saying, okay, bringing in the surface, what do you want to do? Do you want to use that surface data to derive the cover levels for the manholes, or do you want to leave them as they are, or do you want to go through individually and specify on an individual basis which ones are kept and which ones are overwritten by the surface data? Doesn't really matter in this case. I'm going to keep my existing cover levels, but the principle's the same. You end up with, if you click on a manhole, you'd end up with a cover level. You can see in this case 0 because I didn't overwrite it with the surface data as I imported it. We can switch it on to see the one that you should be familiar with if you were following along from session 1. And that's it. It's as easy as that. That's the principle, is that prepare your data perhaps outside of InfoDrainage. As I said right at the start, this course does not focus specifically on the interaction between Civil 3D and InfoDrainage. There's a separate session purely on that, and we think that eventually that's going to be the main way that people are going to manage their data. Prepare everything in Civil 3D, come out perhaps temporarily to InfoDrainage to do the hydraulic design, and then take it back into the Civil 3D environment for further processing, presentation, that kind of thing. So we can save our work at this stage. And as a short additional exercise, we're going to look specifically at the import of MicroDrainage models. So again, let's start completely from scratch. So if you go File and New, and I'm now going to save this as, let's call this exercise 4A. Save that. And we're going to import a MicroDrainage file. There's a specific button for this. Import design from MicroDrainage. Just press on that button. We need to go back to the data directory, and there's a model here called full digitized model within MicroDrainage. So press open on that. It's asking us to save the file, so I'm going to specify the one that I just created. Yes, I want to replace it. Now at this stage it's giving us some warnings, and this is basically because there are some parameters which exist within MicroDrainage which we considered weren't relevant to InfoDrainage. One feature that MicroDrainage has is the ability to define these PIMP classifications. We've spoken a lot, I've spoken in previous sections about the importance of getting this value of PIMP right, of defining how much of our catchments are roads and roofs and how much are other permeable areas such as front gardens and grass verges and things like that. MicroDrainage has this facility that you can import those polygons of impermeable areas, digitize your catchment areas, and then the software will do the assessment of what those PIMP values are. We don't yet have that in InfoDrainage, may come along at some point. The other parameter that is listed here is this maximum rainfall cannot be imported. This was considered not to be relevant. It was an old theory which we've now discarded, which talks about the absolute maximum intensity of rainfall that could land on a catchment. So simply doesn't exist in InfoDrainage, so it's just giving you a warning about that. Press OK, and it brings the model in. I've got the same model. I'll just show you briefly. In MicroDrainage, it's the model that we recognize because we've just been importing the data separately. But it looks the same in MicroDrainage and InfoDrainage. We went to the effort of digitizing the catchment boundaries within MicroDrainage prior to import. One thing again to be reminded of at this stage is that the underlying mathematics within InfoDrainage, the simulation engine, is different from MicroDrainage. There was a number of reasons that we switched simulation engines. It's now more robust, more flexible. However, it does give, in some situations, different answers from MicroDrainage. And the question we often get is, well, you know, you've got MicroDrainage, InfoDrainage, they're giving different answers. How different are those answers and which one's right? And there's not really an easy answer to that. The answer we give is that they're both right. They're both trying to represent what we see in reality. They are both an approximation of reality, and they are both good approximations of that. How different are they? Really depends on the situation. In a simple single pipe run where the pipes aren't surcharged, the results are very, very similar. There's some things in particular that InfoDrainage represents which MicroDrainage doesn't. For example, full backwater effects. So if you had a river or a tidal influence downstream, that now flows backwards up through the system. MicroDrainage does not have those full capabilities. So in situations like that, the results would be quite different. So it really depends, but they are trying to do a very similar thing. They're trying to replicate what's happening in reality, just two different methods of achieving that. Now I also want to show when it comes to the import of MicroDrainage, and this is really, I think, only of relevance for people who are converting from MicroDrainage. Looking at MicroDrainage now, those of you who are familiar with it will know that there are actually three separate places, locations, in which we specify rainfall. The first is the design criteria. So if we look under network and then design criteria, so this would be our typical 1 in 1, 1 in 2, 1 in 5 year return period storms, the basis of designing our pipes initially. Then we've got the site and simulation criteria. Now if we were to just hit that green go button in MicroDrainage, it would run just this one storm. So in this case a 5-year 30-minute summer storm, it would run just that one. However, that as a process has largely been overtaken now by the seasonal return period wizard, and within this we can run a variety of storms. So we've got a range of durations, summer and winter. We can have multiple return periods if we want to, but this would run a series of storms. Now looking in InfoDrainage, if we look at the rainfall and the rainfall manager, we can see here that there are those three rainfall sources which have been imported. So we've got the simulation criteria there, where if you remember from just a second ago we had a 5-year return period, and a variety of storm durations. Sorry, just one storm duration from the simulation criteria. We've got the design criteria, which is typically a lower return period, perhaps 1, 2, in this case 5. But again, this would be the basis on which we design the pipes. Stage 1 of the two-stage design process, which was mentioned in section 3. And then finally, we've got the SPR wizard, which runs both summer and winter storms, possibly at a variety of return periods and possibly at a range of durations. So all three data sources have been imported. By far the most common one that we're going to use is the SPR wizard, this ability to run a series of storms and pick the worst one. And that's what we're going to do now. So the way we do that is if you go into the analysis drop down and then set the analysis criteria. Here's the 3 rainfall types, and we're going to use the SPR wizard, just that one, and we should see that there are 18 storms. It's 1 return period, 9 different durations, both summer and winter. We're going to run at an output interval of 5 minutes, so we are only going to get a result presented in the graphs or in the tables once every 5 minutes, which is probably a bit long in reality. I'm only using it in this case so that the simulations run quite quickly. We're not going to do a detailed analysis of the results, so I just want some results. I'm not too bothered about the granularity at the moment, so we're going to use that. And I think that's all set up. We're using the default time step as we've used previously, and if you haven't been through previous sections, just be aware that we normally recommend the shortest. That gives us the best chance of the model being stable, but again it impacts simulation times and we're not worried about detailed analysis of the results, so that's fine in this case. So press OK on that and then validate the model. We should see that there are no errors. The MicroDrainage model was used to run simulations, so importing it also allows us to run simulations. It's good practice just to save the model prior to running it, so I'm going to save it in this case and then press go, and it runs through and does that analysis. Now I did foreshorten that, so I did pause the video at that point. It normally takes, on a reasonably spec computer, it would take less than a minute, but still a little long to be sitting there watching it. And just like we've done in previous analysis, when we did the two-stage pipe design, is once you've got the results, you would press on the critical storm. It would pick out the worst storm, which would be listed there. Again, we can see it's predominantly the 15-minute winter, although some of the pipes are susceptible to the short summer storms as well. And then just like we did before, we can look at the results in a variety of ways. We can tabulate them, we can graph them, etc., etc. But that's it for the way that data is imported from a variety of sources, including MicroDrainage models.